All right, so this is I broke up Module 2 into two video recordings only because I think the second part where we're going to really start to deal with Visual Studio is one that you might want to turn back to a few times as you start writing some of your own programs. We're going to be using Visual Studio to write all of our C++. And that's only kind of part of the story because we're going to write our actual code in Visual Studio. We're going to build it, but then we're going to also have to run it. And we're not going to actually run the programs through Visual Studio. We're going to run it through what's called the command prompt. So this recording is all about writing our first C++ program. I don't want to really focus on any of the syntax. In fact, this is the program we'll write. I'm almost just going to paste in this syntax. I'm not going to really worry about discussing it that much just yet. I want you to focus predominantly on what I'm doing in terms of Visual Studio, and I've sort of I've widened out what I'm capturing on my screen so you can see how I'm accessing everything through Windows. My machine is Windows 7. If you're using Windows 8 or above, that might start to look a little bit different. But all the functionality should be the same. We can download Visual Studio and install it on Windows 8 on any subsequent version. And the command prompt will come with that as well. All right, so we're going to write this program that's really just going to say, welcome to CMPS 147. The first thing that I want to do is start up Visual Studio. So I'm going to access my Start menu, and if you've installed Visual Studio already, if you haven't, obviously you need to do so. If you have already, you will have down in the Start menu Microsoft Visual Studio. You may have Visual Studio 2013, 14 should be out soon, so if you might download that, that's okay. I have 12 on this particular machine. The version really doesn't make that much of a difference. Again, the version that you download probably will be the Express edition for Windows Desktop. So you might have something slightly different than this. I'm going to start up Visual Studio 2012. Again, like you can see, mine's Ultimate Edition. That might not be the case on yours. When you first launch Visual Studio, it's very likely to look a little bit different than this. First of all, you might have like a lighter theme to it instead of the dark theme. 2012 came with dark theme. I think in the 13 edition, it starts out light. I think you can always change that. While it might visually look a little bit different, the programs function in the same way. Okay, so all the steps that I'm going to do here are the same. So before we write any C++ code, what we have to do is we need to create a project. In Visual Studio terms, a program equals a project. The word project is synonymous with a program. So to do that, we can click on New Project. There's a variety of different buttons to do that. I'm just going to say New Project. And it takes a moment. If this is the first time you've used Visual Studio on your machine, it could actually take even longer than that. Be a little patient with it. It will speed up after a while. Once you get this New Project dialog, there's a couple of really important things to look at here. First of all, we need to choose the right project. There are what are called project templates in Visual Studio. And again, depending on the version you have, you might have much fewer options, but you will certainly have more than one option to choose from. Visual Studio is a professionally oriented programming environment. It's a big tool, and it supports a variety of programming languages: Visual Basic, C#, C, F#, Python. There's lots and lots of languages supported here, and within each one of these types there's quite a few number of different types of programs you can create. Every single one of the programs that we create in this course will always fall under Visual C++, and the visual part is really not that critical. That's a Microsoft term. It's C++. It's regular C++. We'll go under General and we'll select Empty Project. All right, every single time it'll be an empty project. Down over here, what you want to do is you want to uncheck create directory for solution. If you forget that step, it's not the end of the world, but your directory structure that will be created within the project, because Visual Studio is going to put your entire program, all the files associated with it, and you'll be surprised at how many files Visual Studio actually creates. It's going to put it all under a directory structure, a set of folders on your machine. If you create the directory for the solution, it'll be a little different than what you see that I'll do right now. And so to avoid any confusion, you want to make sure you unclick that. But again, if you don't unclick it, it's not a huge deal. Next, we're going to name our project. Try to name your projects with reasonable terms. If you're, don't call them project 1. If you're creating, lab 5, call the project lab 5. Just makes sense. Ultimately, the name of the project really does not make much of a difference, though. I probably won't even see the name of the project that you create, but I will give you one rule, and this rule I'll repeat in a number of different places today. Do not put a space within the name of your project or any of the directories, and I'll talk about the location in a second, or any of the directories in your location path. If you put a space, again, it's not the end of the world, you're not going to lose your code, but everything will be more difficult for you. You'll have to do more typing. It just won't work as nicely. So please, if you're going to remember anything about the names of anything when you program, do not put a space. Don't say project space 1, don't say homework space 2. Always remove all spaces from the name. So I'm going to call this demo. That'll be the name of my project. Next, I'm going to have to select a location. Now I'm going to keep this in my C drive CMPS 147 under online. You will want to click browse and actually find a location on your hard drive, in this C drive or wherever you want to store it, where you want to start to put your programs. What will happen is that there's going to be a folder called demo be created in CMPS 147 online. Again, try to keep this path short. Don't put this in documents and settings or my desktop or anything like that, where you've got a lot of folders here, because you're going to actually have to manually type all of this. So keep it short. Create one simple folder underneath the C drive called CMPS 147. You probably don't even need the online, and just store all your stuff there. Once you select your folder, that I would recommend just staying in the same location for all your projects, and then all the code for this entire course would be in the same directory for you. It'll keep things a little bit more easy. Visual Studio will remember your selections other than the name of the project. So the next time you start it up, it's going to be highlighting empty project. This will be unchecked, and the location should be set. But always, just double check that. Just make sure you give it if you're on a public, like a lab machine or something like that, certainly you want to check that each time. Okay, so I've selected empty project, I've named it, I've set a location, and I've created a directory for the solution. I've unchecked create directory for solution. So when I click OK, Visual Studio takes some time to create a directory structure for me. Again, this could vary how much time this takes for you. Before talking too much about Visual Studio here, I want to show you what just happened on my C drive. So if I load up just regular Windows Explorer and I go from my computer to C147 online, you can see that my demo has been created. Inside it, right now there's no C++ code at all. I haven't done anything, and Visual Studio has already created several different files for me. None of these files will be particularly useful for us. Visual Studio uses them. You can kind of think of it as all this stores all the little details for Visual Studio to know how to build your machine, your program. So they can be safely ignored for now. What I want to point out again, though, is where this is located. Right, I've created my directory structure. I've saved it to underneath online demo. You want to make sure that you note where you're creating your programs. That's sort of should go without saying, but you're eventually going to have to upload these things, so you're going to have to find them. So you want to make sure that you don't kind of go too fast and forget where you've saved stuff. You can also see in Visual Studio down here, it'll tell you where it's created the project. There's a project file with a VC blah 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 extension, and that's not that critical, but that'll tell you where the path is. So when you start up, you're probably going to have a blank screen. You'll probably have an output window at the bottom. You'll probably have Solution Explorer over here, either to the right or to the left. It doesn't make much of a difference where it is. And underneath Solution Explorer, you'll see the project name demo, and then a list of directories that have been created. They're actually not real physical directories on your machine. They're just for organizational purposes. We're going to end up creating a C++ file underneath this source file directory. If you don't see these, if you don't see the Solution Explorer, just go to View and click Solution Explorer, and that'll toggle that back on for you. So now we have a project, but we don't have C++ code. So what I'm going to do is I'm going to right-click on source files. We're always going to add our C++ code to source files. I'm going to say add, and I think this is going off the view of my recording here. So let me make this a bit smaller. If I right-click and I do add new item, so right-click source files, add new item. I'm going to select a CPP file. So it'll always be under Visual C++, and it'll always be the C++ file. Header files, all the rest of these things are not going to be dealt with for this course. You can see the location, so it's going to be created in that demo directory for the project name. And you probably don't want to name it source. You don't have to necessarily name it the same thing as the project name. But you can. There's no reason you can't. Again, don't put a space in the name. Name it reasonably. Make sure the name, identifies what the program is, and then just click Add. Let me re-enlarge this. So now we've got demo.cpp underneath the source files. If you want to make your font bigger, you can hold down Control and scroll up and down, or hold down Control and press plus and minus. I'm going to make this a little larger so we can see it on the video, but you can keep it how it comes as default. Now inside demo.cpp, I'm just going to start typing, and this is what's coming from the slide. So if you look at the slide of our first program, I'm just copying essentially what was there. And a couple of things I want to point out as I go. Notice Visual Studio is doing what's called syntax highlighting or syntax coloring. We're not going to really talk too much just yet about the syntax, but if you're typing along, or you ever find yourself doing this and you don't see some of these familiar colors, after a while you'll know that namespace is supposed to be in blue. Recognize that it always indicates that you've mistyped something. C++ is very, very specific. So this syntax highlighting is sort of an aid to you as a programmer to know that Visual Studio is understanding what you're typing. I also want to point out the little star over here. Whenever I've created any code or I've changed this file, it's not saved. I can do file save demo.cpp, but more often I'll just do Control S. So if I do Control S, that'll save it. That doesn't actually create any runnable programs or anything, but you want to make sure that you have saved your code, obviously, in case something goes wrong with the program. So I'm just going to fill in the rest of this code and just pasted that in there. Okay, so we've got welcome to CMPS 147. This is our first program. Next step, we've got our source code, but remember, based on what we talked about in the past modules, C++ code doesn't get executed by the computer. What gets executed is binary, the binary executable file. So if I go back to my Windows Explorer, I can see demo.cpp. It's a C++ source file. It's what I'm seeing inside Visual Studio over here, just like you'd see a document file and you'd open it in Microsoft Word. While this is always what I want you to submit through Moodle, the .cpp file, that will have the actual text. And in fact, if you open it in Notepad or any kind of other thing, you'll see the same thing as you see over here. It's just a text file. But to run the program, we need to build it. Right? So let's build. Build is synonymous with compile in Visual Studio. Remember, the compilation step, the compile step, turns your C++ code into assembly code, then turns your assembly code into executable binary code, and it stores it in a new file. So I'm going to do right-click on the project, and I'm going to select Build. Now down in the output screen, I see that the build is started, and now it says build succeeded. If I was to mistype something, let's remove that semicolon and do a build, I would get an error, and it might come up like this. It would say syntax error, and this one's pretty self-explanatory, missing semicolon. And we haven't really learned about why you need a semicolon there yet. Sometimes syntax errors will be really specific, sometimes they won't be. If you get an error, you can't run your program. If you get an error, the C++ code has not been built to an executable. So you need to always, whenever you're building, and by the way, it automatically saves the source code when you build. Whenever you build, you have to make sure that you see that one succeeded. If you don't, then or possibly up to date if you haven't made any changes. If you don't, and you see something has failed and you have a syntax error, you can't just sort of pretend it didn't happen. You have to stop, you have to fix it. There's really no way to proceed to the next step unless you get that to compile correctly. Now, once you have that, I'm going to show you a couple of different ways of running the program, and I'll show you the right way to run the program. I'll start out actually with some wrong ways. So if we look down at this in this output file, we see C drive, CMPS 147, online demo. A debug directory has been created. And debug means, in programming speak, it means test. You're testing your program. So it's created a program called demo.exe, and it takes the name from your project. Right? So if I called this anything, CMPS 147, the name of the executable, the .exe file, still would have been called demo. It's based off the name of the project. It creates that demo.exe file in a debug directory underneath the directory named after your project. If we bring up Windows Explorer, we can see that that debug directory has been created. And if I click in it, I've got lots of stuff going on in here, but the only one that I'm really worried about is this exe, the application. At this point, I want to mention that if you're on Windows 8, if you're on Windows 7, by default, sometimes these extensions, this .exe, are hidden from you. So if you're seeing in here just demo, and it's the application type, it's the type of application, you might want to go to Organized, Folder Search Options, View, and let's see here, where is it? Uncheck Hide Extensions for Known File Types. If that's checked, you're going to see something just like demo, and that's kind of hard from your perspective. As a programmer, normally people will turn this off. From a user's perspective, you normally don't see all these type of files. But now that we're actually doing programming, it's kind of unhelpful to see a bunch of files named exactly the same thing. So we want to unhide that. Now, if I click on, most time you want to run a program in Windows, you just double click it. And if I run it, you can see if you're quick, it actually just runs really quick and disappears. It's just this black window. That's because this program's not really a Windows program. It's not a program with a graphical sort of user interface to it. It's just a command line program. It just prints out text. And in order to print out text, the Windows actually creates sort of like an old-fashioned type environment for it to run in, called the command prompt. It's basically looks and feels a lot like the predecessor of Windows back in the early 90s, 80s, called DOS. And it looks like a regular command line. That's what you're sort of seeing flashing across the screen, but because our program is so fast, basically we just say, welcome to CMPS 147. This takes a few nanoseconds to execute. The program starts and exits immediately. So we don't want that. Another method would be to do local Windows debugger, or to do debug and then select something like run. Okay, so if we did start debug, basically we'd be doing the same thing. We would get into this debugging step. The program will take a second, but then it'll stop as well. So those are two ways to run the program that are effective in other contexts. They are effective if you're running your different types of programs. They're not effective for our purposes. For our purposes, what we really need to do is not rely on Visual Studio, not rely on our mouse. What we need to do is we actually have to get into that old type of an operating system called DOS. We need to get into that command prompt environment, which, by the way, is still very popular. Most programmers work with it with a command prompt. Seems a little backwards if you've never done it before. Takes some time to get used to. But as you do get used to it, it's actually a little bit more efficient and a little bit more powerful than the regular mouse type interface. We have to actually start using that. So in Windows 8, Windows 7, if you go to your Start menu and you go to All Programs, and if you go to Accessories, you'll find a program called Command Prompt. And if you've never used it before, you might have seen it at some point, but you didn't really know what to do with it. So we'll click on Command Prompt. Command Prompt is, again, like I said, it's sort of like an old-fashioned way of, or primitive way of navigating a file system. And when I say navigate a file system, what do I mean? Well, Windows Explorer, this window that I've been using here, this lets you navigate a file system. Your C drive is a file system. It's a system of directories with files in it. I have CMPS 147, online, demo, debug. That's where I currently am, and that's the full path. And I can browse by just simply clicking on folders. I can go to different locations, click on folders, navigate through them. I can click back and to move back to a different spot. The command prompt does essentially the same thing, but not graphically and not with the mouse. So the command prompt prints out to the screen the current directory that it's currently in. And in fact, I can do this. I can go to C drive in Windows and go to, I can go to C drive users, sfreeze, and I've got all this stuff here. And if I can see it, and I can also type in command prompt dir, and it will list it. And if you look closely, it's all the same stuff. All of the same folders that are in users sfreeze are also displayed in the command prompt. The command prompt is just another way of viewing your directory structures. So my program is not in users sfreeze. My program is in C drive 147 online, and then demo. So that's my path, C147 online demo. Now to do that in Windows Explorer is pretty easy. I just clicked all the way back to the C drive, and then I just double clicked on all my folders. In command prompt, it's a little bit more tricky. To change directories, we type CD space, and then we're going to actually enter in, and let me make this a little bit bigger. We're going to enter in, let's see, we're going to enter in our destination. The destination directory is always relative to your current directory. So C users sfreeze. Now to get to 147 online demo, I have to go all the way back up to the C drive. To go back, to go up one level in Windows Explorer, I would just click back, or I'd just click something up here. To do the same thing, to navigate up, I do cd space dot dot, period, period. That goes up one level. And so you can see when I hit enter, I can see now my current directory is C users. If I go back up another directory, I'll be up to the C drive. Now I want to go from the C drive to 147. So I type in cd space cmps 147. If you created a different folder, obviously, you need to use something else. cd space cmps 147, enter, and now I'm in that directory. If I do dir, that's going to list, and I can see my face-to-face online videos, all that kind of stuff is in here, which is the exact same view that I see over here. Two different ways of viewing the same underlying system. If I do cd space online, I'm in this directory with all of my programming examples. I can see the same thing in the command prompt with dir. If you're on a Mac or you're on Linux, you can have the terminal application, which looks very similar to this. The commands to change directories are still cd. However, to list the directories, it's ls instead of dir. I'm going to go cd demo, and I can see that I'm in here. And I can see my .cpp file in both places. Now remember, to run the program, we open a command prompt to run the program. So I'm going to go into my executable is not this. This is the source code. The CPP file can't be run. What can be run is this demo.exe, which is in the debug folder. So I'm going to type cd debug, change directory to the debug folder. Now I'm in the same directory as the executable. I can see demo.exe, and I don't need to keep typing dir. I'm just sort of doing that so you can see. To run a program, type its name, demo.exe. And when I run it, I can see that text has printed out the same text that was in my code up here. Now the program stops, but the command line comes back and it doesn't go anywhere, and it's much more convenient. Don't close this. Leave it open. If you want to run the program again, you can just hit the up arrow on your keyboard and it'll just go back to the last thing that you typed, and you can run the program over again. So it's a good idea to kind of get the command prompt to the right spot, run your program, but then stay there forward. Just keep that window open. You can always switch back to Visual Studio. If you close it, you have to go through that whole process again. You don't lose anything other than time. It just takes a little bit more work. So if I go in here and change this and say this is our second program, and I save it, I want to point out that if I go back here and run this, I see the same thing. I don't see second, I still see first. Right? And that's because there's not a direct connection between demo.exe and the source code. The source code needs to be compiled. No, don't forget that. The source code always needs to be compiled when you make a change for the executable to have that change in it. So this is sort of the source of your instructions, but this is actually what the CPU uses. If I build it, and now I skip back, take a second here, now I can see this is our second program. So our workflow, as we start to write more and more programs, is going to be bouncing back between Visual Studio and the command prompt. We'll spend 98% of the time talking about code, not talking about command prompt. In fact, at this point, everything that you've seen, this is about a half hour into this lecture, everything that you've seen here will be exactly the same for every program you write other than the code. The way you create a project, the way you use the command prompt, the way you run the program is going to be exactly the same. So while this can be a little overwhelming at first, using the command prompt, using Visual Studio, clicking all the right buttons at the right time, after you do this a few times, you've actually now learned everything that you need to know for the rest of the course to be able to run every program and to create every program we want to use. So you will get good at this. This will become easy. But it's just going to take a little bit of the time if you've never used anything like this before. Alright, so at this point, I want to switch back now to the slides, and I do want to talk a little bit about what's going on with all of this. So when we wrote this program, there's two main parts to the application, to the C++ code. There's this section above, this include and using namespace. If we look over here, this part up here, that's going to, it's called the preprocessor directives. It's a set of preprocessor directives, which sort of sounds like nonsense at this point. We'll come back to the details of it, but one of the things it allows us to do is to draw in other people's code. This include statement is actually going and finding a file on our system that's installed with Visual Studio called IOStream, and IOStream has C++ code in it. And it has C++ code to make cout, which we'll talk about in a second, actually work and print to the screen. You can think of it as the code that turns these characters into pixels and actually draws them to the command prompt. To some extent, that's a little overselling it, but that's kind of what's happening. So all of our programs will have this. Sometimes our programs will include more files than just IOStream. They'll always have using namespace, and we'll kind of punt on that for now, and we'll come back to explaining what namespace std means in a little while. The second part down here will always start the same, and this is our main function. It's a group of code. So in between these braces is what's going to form a group of executable code. We'll always have a main group, so it'll say int main with open and close parentheses followed by one of these braces, and then inside our code, and these two lines with returns, maybe 3 lines, this is where everything will be different for every program you write. Depending on what you're trying to do, you're going to write different code here, but the rest of it will essentially be the same. So as I mentioned, we've got our include directives. We'll ignore namespace for now. Inside the main function, we want to now start to think about those curly brackets as being what are called sort of delimiters. And there are a lot of delimiters in a programming language. There's a lot of basically special characters that tell the compiler what you're trying to communicate. We've seen these braces. We've seen the semicolon, and that's another delimiter. In fact, these arrows are also delimiters as well. We'll have to spend more time really learning about exactly why is it that we're putting semicolons here and arrows over here and braces over here, but it'll start to fit in after we've seen enough programs. Because it's so important, printing, let's talk a little bit more about it. Printing is achieved with this what's called a cout statement, and the reason it's cout is it's command prompt or console output, and certainly whatever we printed out here, whenever we wrote inside these quotes, sort of somehow magically appeared on the console when we read it, when we ran the program. So cout is how we're going to be printing out to the console, and later on we'll learn how to read in from the console and do a lot of other things in terms of printing. An output command starts at cout and then is followed by these arrow notations, these double arrows, and the direction makes all the difference in the world. We have to have it pointing out this way, so it's a less than sign followed immediately by another less than. And then we can print something out, and we can print multiple things out. These are called insertion operators, and we can have as many as we want, and we print strings or we print end of lines which go to the next line, and that's the reason why after 147 we're going to the next line. Now in the textbook it'll talk a little bit more detail about printing in the first chapter, and then we'll discuss it in a little more detail as well as we continue. The next thing, or the last thing I want to talk about in terms of just some of the basic layout of code is not everything counts. Everything here, basically the compiler needs to understand it, and it's going to compile it, and it's going to create binary instructions for everything that you type, and everything that you type has to be very specific at this point. However, it's nice to sort of be able to write you know, the name of the program, and what it does for someone who's actually just looking at the code. This is called a comment. And a comment can start with a double slash, and everything else will turn green on that given line. If I go to the next line, it won't be green, it won't be considered part of the comment. Comments are totally ignored by the computer. When you compile your C++, the comments don't get into the binary. They have nothing to do with the execution of the code. They're 100% for someone reading your code, somebody like me. So when you write some code and you write an assignment, you want to put your name on it, right? So you can put, you know, this is, you know, Lab 1 built by Scott Fries or whatever your name is. And we don't have to actually just do one line at a time. We can also do a /* followed by a */, and everything, no matter how many new lines occur, everything will be a comment between those delimiters, those markers. So again, we've seen sort of these as indicating the start and end of a group of code. We see these marks as a start and end of a multi-line comment. And again, we can do single line as well. So, as your first lab, what I'm most concerned about within these first few days of you taking the course is making sure that you have access to Visual Studio. That you can install Visual Studio and work with it, or again, if you don't have access to a Windows machine at all, we'll be able to figure something out. You might have to install a similar program on your Mac called Xcode. If you're using some other platform, I can help you with that as well. But I would strongly recommend that you have access to a Windows machine and use Visual Studio. Even if you have to, you know, borrow somebody's for the beginning portion of the semester, do that, and then once you've mastered Visual Studio and you understand it, and when I say master, basically be able to do what you just saw me do. That's all we'll have to do with Visual Studio. Once you're comfortable with it, then I can help you with another, you know, with a Mac or something else. So because it's important that you can do that right now, or within the next, you know, few days at best, or at worst, because not being able to write code will cause you to dramatically fall behind. So we need to get you writing a very simple C++ program. Even if you don't know why it works, you want to be able to create a program and run it on a machine that you're going to have access to, that you can do your work for the rest of the semester on, or at least for most of the semester. So I want you, as the first lab, to just create a Visual Studio project. Doesn't matter what you call it. Use the steps that I've outlined here. If you haven't installed Visual Studio, go on to Moodle, go to the instruction link for downloading and installing Visual Studio. Do that. Write a C++ program that simply prints out your name. So, you know, just the only thing that I really want to see different is, you know, see out whatever your actual name is. Obviously, don't just do your name. Whatever your name is, print it out, and that's all. I just want to see that source code. I won't really know for certain that you ran the code. You're only going to submit this .cpp file. Right? And so when you go to submit that CPP file in Moodle, you're going to browse, right? And if you remember from the first module, I showed you some links on how to do that on Moodle. You're going to scroll down to Lab 1, you're going to click on it, you're going to say Add a Submission, and you have to make sure that you browse to this .cpp file. Find the source code, the C++ source code, not the executable, and not one of the possibly many other files that are called demo. So part of this lab is making sure that you upload the right source code. The other part of this lab that I can't really necessarily verify is that you run your program, through the command prompt and you see that it works. If you don't do that at this point, and then, you know, come the due date for the rest of the labs, you're going to have a lot of problems. So please make sure that you take your time through this and make sure that you can run a program and submit that.